Hello students, welcome to fourth video of assignment 7.2. In first video of this assignment, we had differential equation of charge for series LCR AC circuit. In second one, we did derive expression for current when we have all the three components, inductor, capacitor and resistor connected with alternating source. In last video, we considered only two components, resistor and inductor connected with AC source in series combination, and we saw how current varies with time and how voltage varies with time for such circuit. Today again we will be considering only two components R and C when they are connected in series with some source of alternating voltage. How current varies, what is the nature of current, we'll check that, and we'll plot graph of current versus time and voltage versus time. The question is, write expression for complex current for AC circuit with series combination of resistance and capacitor. Draw graph of current versus time and voltage versus time. So before we get into the topic, let us recall the expression of voltage and current. So in complex form, V is Vm e raised to j omega t, which can be written as Vm cos omega t plus j Vm sin omega t. Though we'll not be using this part, it is imaginary, so it's not used to represent voltage on graph. Real part is used. Similarly, uh, we had Z impedance R plus J omega L minus 1 by omega C. This is for series LCR AC circuit. Right now we are talking about RC circuit, so we may not be using this, we will not be using this. And then we had equation of current I is equal to Im e raised to j omega t minus delta, and if we represent it in terms of real and imaginary part, it is Im cos omega t minus delta plus j Im sin omega t minus delta. Once again, this part will not be using. So this is the equation of current which we have. This is Z in general for LCR AC circuit, and this is the equation. Okay. So for the given circuit, we will first decide what is Z, and then we'll check current equation. Which circuit we are talking about? We are talking about a circuit where we have resistor connected with capacitor in series, and then this combination is connected with source of alternating voltage. So for this circuit, I should be able to write Z as R minus j by omega c. There is no inductor. Okay, so I don't need this term. Now, how do I find out mod z? How do I find out delta? I need to find out, say, to derive equation of current, we need delta. So, how do I find out delta? I'll have to represent this z on complex plane. So, how do we represent it? Start with complex plane. So, here is the complex plane. My second term is negative. Okay, so I'll have to consider it here, 1 by omega c. So this is 1 by omega c negative, and let me consider this much as real part, resistor. And then I can say that this is impedance Z, and here is the phase of the impedance. So if I'm asked how much is Z, I can say that magnitude of Z is R square plus 1 by omega c whole square. And if I'm asked how much is the phase of the complex number, I can say that phase of the complex number is 10 delta, which is equal to imaginary part 1 by omega c upon r You can write it as omega RC. You can write it as 1 by R into XC. All these are different ways of writing same thing. Okay. The essential part is we should be knowing how to find out delta. If you have values, you can substitute in this equation and you can find out how much is the delta. So once you define delta, you can use this equation. Okay, and now I can write that V is Vm cos omega t, and from this graph I realize that delta is negative. Okay, and then in this equation, if I take negative delta, I will end up with I is equal to Im cos omega t plus delta. Okay, now look at the condition. We have voltage as Vm cos omega t, current as Im cos omega t plus delta, and if we are asked what is Im, we can say that Im maximum current is maximum voltage divided by mod Z. What is mod Z? We already have defined it. Okay. So both these are function of cos. Voltage is function of cos, current is also function of cos, with the difference that voltage varies as omega t term and current varies as omega t plus delta. It means phase of current is more than that of voltage. Current is leading. If you remember the case of LR circuit, in LR circuit, if voltage is cos omega t, current was Im cos omega t minus delta. So phase of current was less in LR circuit. So in LR circuit, who is leading? Voltage is leading, phase of voltage is more, so voltage is leading current. But in LC circuit, sorry, in RC circuit, current is leading the voltage. Phase of current is more, so current is said to be leading the voltage. But as both are function of cos, when you plot the graph, you should be careful about that fact. So first let me plot voltage graph. So if this is the voltage graph, how do I plot current? How do I take care of this fact that phase of current is more? So before we reach zero of voltage, before voltage reaches zero, we should indicate that current has become zero. Okay, so voltage is zero here. So before voltage becomes zero, current should be zero. Then only we can say current is leading. Similarly, when voltage arrives, suppose at this time voltage is arriving at its maximum value, current should reach its maximum value sometime before that. Okay, so with that thing in mind, I can say that current can be shown like this. This gap is our phase difference delta. More the delta, more the gap, phase difference. So this is the current, here is the voltage, and this is having time as horizontal axis, and this is the nature of current for series combination of R and C. Okay, so that was the topic. Thank you.